Hello everyone, this is teacher Justina and welcome back to my channel. If you are still new, then do not forget to subscribe, like, share, and hit the notification bell for more video updates. And also, you can leave your comments below and you can also suggest topics. And then another thing, you can please do watch my video from the very beginning all throughout the end because I am giving examples from easy to difficult. And our topic for this video is all about simplifying rational expressions. Okay, so at this time, we will familiarize a rational expression. So what is a rational expression? It is an expression of the form P over Q, where P and Q are polynomials and Q should not be equal to 0. Uh, what's wrong if Q will be equal to 0? Okay, it is already understood that if our denominator as Q will become 0, our expression will become undefined. So it is already known that any fraction with a denominator of 0 will become undefined. Another thing, a rational expression, it is also a ratio of two polynomials. So let us have this examples. You have x over 5. Okay, this is an example. 3 over x minus 2, x squared plus y squared over 4, and then the two remaining rational expression. As you have seen, if we will try recall, if they are expressed as a ratio of two polynomials, we know for sure that polynomial is an algebraic expression in which the exponent of any variable should be a positive integral number. So when we say integral, it should be a whole number, never be a decimal, never be a fraction, never be negative. Okay, so therefore, each of the given rational expression, they are all expressed as two polynomials. On the other hand, these following examples cannot be considered as rational expression. Okay? And why these belong to non-examples or they are non-rational expression? Because as you have seen, our denominator is consist of a fractional exponent. Okay, this make this algebraic expression non-rational. And then the second example, the square root of x. Remember that the square root of x can be also expressed as x to the power of 1/2. So the square root symbol there uh, implies that if we will be expressing square root of x to a fractional exponent, so therefore x to the 1/2 is not a polynomial. As well as the third example, the x there has 1/3 as an exponent. So they are not expressed as a rational expression. Okay, which of the following are rational expressions? Let us try C. Okay, number one, yes, it is a rational expression. X plus 5 over 7 is a rational expression because both the numerator and the denominator are polynomials. Let us have number 2, 15 plus x over 5x minus 1. All you need to do is you try see the exponents of our variables. Okay, and number 2, still, yes, it's a rational expression since both numerator and denominator are polynomials. But number 3, the x cubed minus 2 over 5 minus square root of x, it's not a rational expression since the denominator 5 minus square root of x and that square root of x um, makes this entire expression number 3 not a polynomial because square root of x does not define a polynomial. Okay, so to proceed, let us find out as to which of the following expressions is in Lewis terms. And then let us try uh, this letter A. Letter A is Is this x over 5 in lowest term? Okay, yes, this is already on its lowest term because there's no common factor for the numerator and 5. So they are both not factorable anymore. So this is already lowest term. And then letter B, is this already on its lowest term? No, this is not because the 10x and the 15y, the 10 can be factored out as 5 times 2. Then there is an x there. And then in the denominator, we can also have a 5 times 3 and then y. And then as you have seen, our uh, greatest common factor in the numerator and in the denominator is 5. Okay, so the remaining term is 2x over 3y. So therefore, if we are to simplify further, letter B, uh, it will be 2x over 3y. So letter B, it's not on its lowest term. Okay, so this is not on its lowest term. And letter C, we have the 3x minus 5, and there's no such common in 3x and 5. Uh, in 9, okay, this is already considered lowest term because remember that uh, it is not correct if we will be considering to factor out 9 into this way and then canceling the 3 and the 3 there. It's not possible. Why? Because the 3 there, it is with x and we have a minus 5. So this is already a binomial. We can only cancel them if and only if the the operation between them is multiplication. So again, letter C, this is already on its lowest term. And then letter D, let us try see that in our numerator, we have two terms. And in that two terms, you have seen that the 2 is common to 2x and 4. So we will be pull outing the 2 there. So we have 2x divided by our common monomial factor. So will be x. And then 4 divided by 2 will gives us a 2. And then remember that 8 can be also factored out into this way. In such a way that we can now cancel because this already gives us a quotient of 1. So therefore, the simplified form in that letter D is x minus 2 over 4. Again, we cannot do cancellation into n4 because this is not equal to 1. And at the same time, the numerator x minus 2 is a binomial. So therefore, letter D, this is not on its lowest term. Okay, let's proceed. We are going uh, to find out as to how to simplify a rational expression. So how to simplify a rational expression? Okay, let us try see as to how to simplify. Let us find out the different steps. So simplifying a rational expression, we have to factor both numerator. We have to factor out both the numerator and denominator if necessary. And then letter B, we have to divide both numerator and denominator by their greatest common factor, like what we did in letter B and in letter D. So therefore, let us try. Let us try simplify the following expressions. So how do we look for the simplified form or the lowest form of letter A, which is 7xy and 14xz? So it is being said that factor both the numerator and denominator. So if you will try C, the 7xy is already on its list. This is already prime. We cannot factor it anymore. But remember that our denominator, we have a 14, and this could be factored out this way. 7 times 2. And remember, there is an x there and there is a y in the denominator. So by this way, we can now start do dividing both. So 7 divided by 7 will gives us 1. The x here and the x here will also gives us 1. So therefore, uh, I'm sorry, this is not a y, but in the given this is a z. So therefore, uh, we will change this as z. So only the x as variable can be cancelled because this gives us a quotient of 1. So for that, our remaining term in that letter A, we have y over 2z. So we are done simplifying. And are we sure that y over 2z is already on its least form? Yes, there's no common factor anymore in the numerator and in the denominator. And then let's proceed to letter B. Okay, the 4x squared and the 12xy. Okay, so of course we have to remember the common monomial factor, and then the 4 there as a constant is common because 4 can divide itself and can divide 12. And there is an x both in the first term and in the second term. So we can pull out the x there as our common variable. So 4x squared, okay, that's one. 4x squared divided by 4x is equal to x, then plus, follow, and then the 12 divided by 4 will gives us a 3, and there is an x here in 12xy, so it is just simple like this, 12xy over 4x. So the 12 divided by 4 we have a 3, and the x and x will gives us a 1, and then therefore we have already here a y. Because if we multiply them back, 4x times 3y will gives us 12xy. And our given here is 12xy. And then over. Okay, remember that sometimes if we are done factoring in the numerator, maybe one of the factors in your numerator, maybe in the denominator there will be also or in other words, there will be a hint factor in the numerator that may be one of the factors in your denominator. So as you have seen, we have here 4x. And in our given, we have 20x cube y. And I'm sure there is a 4x in the 20x cube y. And then for that, we will have to have a 4x. Okay, then you try think what should be multiplied to 4x in order to get the 20x cube y. So far, 20 divided by 4, we have a 5. And then that's x cubed, and this is x to the 1. So therefore, this is x squared. And then we have a y. And then for that, we can now do cancel 4x and 4x because this gives us a quotient of 1. And for that, our final simplified form is x plus 3y over 5x squared y. This is already our simplest form. Okay, so let us explore more. So given this following rational expressions, let us now simplify following the steps. No, we are going to uh, factor both numerator and denominator. So far, we have to do like this. The 8x cubed y can be factored out into this way. 8 times 1 and then x squared, then x and y. Why I am doing like this? Because in the denominator, we have the x squared and y squared. So far, the 16 can be factored out by 8 times 2. Okay, so let us now start dividing the greatest common factor. So the 8 over 8, it will gives us a 1. The x squared and the x squared will gives us 1. The y and the y will gives us a 1. So therefore, what will be the remaining term? The remaining term will be 1x. So as you have seen in there, the 1 and then the x. Okay, so the remaining term will be 1x in the numerator, and in the denominator we have the remaining 2y. Or it could be written into x over 2y. Number 2, as you have seen there, number 2, you have seen in the numerator we have the 3x and 6. And so far the common monomial factor there is 3. And for that, the 3 will divide 3x and 6. So it will gives us x plus 2. So 3 times x was 3x. 3 times 2 will gives us 6. And in the denominator, you have seen also that 3 is common to 3 and 12. And so far, 3x plus 12 divided by 3 will gives us x plus 4. And then for that, the next step is we to divide the greatest common factor, and the remaining will be x plus 2 over x plus 4. And then let's proceed number 3. Number 3 we have, okay, so therefore, uh, number 3 is m squared n minus mn over m squared n. As you have seen that in our numerator, in the variable, we have m common to the two terms as well as the n. So therefore, our uh, greatest common factor, not greatest common factor, but the common monomial factor in number 3 is mn. And that mn, so far again, how will we do it? M squared n divided by our common monomial factor. So far, the n and n cancel. Then remember, this is a 2 and there is a 1. So therefore, the remaining is m minus 1. Okay, so m minus 1. And then in the denominator, remember again, as I've said, sometimes in the numerator, there will be a hint there that maybe one of the factors in the denominator will be uh, coming from the numerator. So m in n is can be found in m squared n, and what should be multiplied to mn to get m squared n will be m. And so far, we can now cancel mn and mn because it will gives us a 1. Again, we can only cancel. The term cancel there is if we will come up with a quotient of 1. And so far, m minus n over m. Or you could remove the parentheses. They are just the same thing. So number 4. This time, uh, this is expressed into x squared minus 9. Okay, this is expressed as difference of two squares. And so far, as our previous video, how to factor out difference of two squares, we know it already that factoring difference of two squares will gives us getting the square root of the first term. So how to get the square root of x squared? That will gives us x. And then the square root of 9 will be 3. And then we have to have x plus 3 and x minus 3, the two identical terms. So the factors of the difference of two squares are two identical terms. When we say two identical terms, they have the same exactly first and the same exactly second, but they differ in signs. What about in the denominator? I'm sure you remember that this is a general trinomial. So what will be the factors of 6 that will gives us a 5 as a sum? So far, it will be x plus 3 and x plus 2 because 3 times 2 will gives us 6. And if we add as 3 and 2, will gives us a 5, and 5 is our middle term. So therefore, is there any greatest common factor? Yes, there is. So x plus 3 divided by x plus 3 will gives us a 1. And so far, the remaining term is x minus 3 over x plus 2, or that will be our final answer. Let's proceed to number 5. Okay, as you have seen, our examples are getting difficult. But anyway, as long as you have all the previous knowledge, the previous mastery of the subject of the previous topics that we have, you will never get lost. Okay, number 5, a squared minus 9a plus 18. Okay, so far in the numerator, this is factorable. What are the factors of 18 that will gives us a negative 9? Remember, what is that note? In factoring general trinomial with a positive third term and a negative linear term, it will always gives us two factors which are both negative. So therefore, negative 3 and negative 6 will gives us positive 18. And then if we will be adding negative 3 and negative 6 will gives us a negative 9a. So therefore, the factors are in the numerator are a minus 3 and a minus 6. So therefore, I'm sorry, this is not x, but instead this is a. Okay, this is a. So therefore, we have a minus 3 and a minus 6. While in the denominator, this is a perfect square trinomial. Why perfect square trinomial? Okay, 9 is the perfect square in which the square root of 9 is, okay, this will be like this. A squared minus 6a plus 9. The square root of a squared is a. The square root of 9 is 3. And then whatever the sign in the middle term will be followed. And then I'm sure remember that if we wanna check if this is a perfect square trinomial, we multiply this one, the first or the square root of the first and square root of the last. So that will be 3a and times 2. So 6a is our middle term. So therefore, the factors in number 5 in the denominator, we have a minus 3 times a minus 3. And for that, what is the greatest common factor? So the greatest common factor is a minus 3 and a minus 3, and that will give us a 1 as a quotient. So our final answer will be a minus 6 and a minus 3. Okay, remember we cannot divide the 6 and 3 there because they are both binomial. Okay, let's proceed to number 6. Okay, number 6. What are the factors of 10 that will give us negative 7 as a sum? Again, we will be expecting to have a factors both uh, both negative because our middle term or our linear term numerical coefficient is negative. So factors of 10 that will gives us a negative 7. So we are expecting to have both negative factors. So we have x minus 5 and x minus 2 because negative 5 times negative 2 will have positive 10. If we will add negative 5 plus negative 2, are we getting a negative 7? Yes, so negative 7 is our middle term. And then for that, our factors in the numerator are x minus 5 and x minus 2. And then this time, number 6, we have already a negative third term, and then we have there a positive 3x. So what will be the factors of negative 10 that will gives us a sum of 3x? So therefore, this will be x plus 5 and x minus 2. Okay, let us try. If we multiply positive 5 and negative 2, that will give us a product of negative 10. If we will add positive 5 plus negative 2, it will give us a sum of positive 3. Is our sum here positive 3? Is our middle term numerical coefficient positive 3? Yes, so therefore the factors of our denominator are x plus 5 and x minus 2. And so far, what are the greatest common factor? The x minus 2 over x minus 2 will give us 1, and the remaining terms are x minus 5 over x plus 5. And let us have this number 7. Number 7, okay, so the factors of x squared plus 5x plus 4, a product of 4 that will give us a sum of 5, we have x plus 4 and x plus 1. And then the common of x squared in x, the common there is x. So therefore, x times x plus 1. And what is the greatest common factor? They are the greatest common factor. Thus, our remaining terms are x plus 4 over x. And remember, do not ever cancel the x and the x there because we have already in the numerator expressed as a sum. Okay? Okay, let us have the last two examples. And I'm sure these examples are different from the previous examples that we have. Okay, so number 8. We have 2y squared minus y minus 3. Okay, so this is already uh, involving factoring by trial and error method. Okay, how do we find the factors in the numerator itself? So we will be finding the possible factors. When we say finding the possible factors using trial and error method, let us try C. 2y squared is our first term, so let us try find factors, the possible factors of 2y squared, and I'm sure it's 2y times y. It's negative 3 in the middle term. I'm sorry, in the last term we have a negative 3. So it could be plus 1 and it could be a negative 3. And then for that, let us try positive 1 times negative 3, we have a negative 3. Positive 2y times 1 will gives us positive 2y. Y times negative 3 will gives us negative 3y, and y times 2y will gives us 2y squared. And for that, we have a negative 3. And 2y plus negative 3y, we have a negative y and 2y squared. I'm sure this is our given. But what if you will interchange the sign? Something what will happen if you first try this 2y plus 3 and a y minus 1, because there are still possible factors of the first term in the given, and the negative 3 we have also positive 3 and a negative 1. So far, how do we now find their product as to get the given? So negative 1 times 3 will gives us negative 3. Negative 1 times 2y will gives us negative 2y. Then the y will be now distributed. Y times 3 will gives us positive 3y and 2y squared. And for that, we have a negative 3, but negative 2y plus 3y will gives us positive 1y and then 2y squared. Remember, our given is not 2y squared plus y, but it's minus y. So the most correct set of factors in number 8 is are only 2y minus 3 and y plus 1. Okay, so that's it. While in the denominator, let us try find its factors. Again, how to get the factors using trial and error. Finding the 2y squared factors will be 2y times y. And let us try a minus 3 and a minus 1. Why? Why we have minus negative 3 and negative 1? Remember, our third term is positive and our middle term is negative. So this will give us positive 3. Negative 2y times, I'm sorry, negative 1 times 2y, we have negative 2y, and y times negative 3 is negative 3y, and that will be 2y squared. And this will be positive 3, negative 5y, and 2y squared. And of course, our first trial, we've got it correctly. So therefore, we will be having the factors in the denominator. We have a 2y minus 3 and y minus 1. And for that, we can now divide the greatest common factor. So the remaining term are y plus 1 and y minus 1. And let us have the last example. 3x squared minus 15xy plus 18y squared over 9y squared minus x squared. So for the factors in number 9, using trial and error method, okay, we have already, first thing to do is we need to get the factors, the common factors of the constants. So 3 is their common So therefore, 3x squared divided by 3, we have there the x squared. And then 15xy divided by 3, we have the 5xy. And 18y squared divided by 3, we have 6y squared. And in the denominator, I'm sure you remember the difference of 2 square. So the factors of that are 3y minus x and 3y plus x. Question, are we done? We are not yet done because we cannot do cancellation because there's no such greatest common factor. So what shall we do next? We will be, we have to try see to it the numerator. Remember that the numerator we have 3 times the x squared minus 5xy plus 6y squared. And so far, what are the factors of this one? So what are the factors of this x squared minus 5xy plus 6y squared? So the factors are, so we have the 3 is here, and these terms inside can be factored out this way. X minus 3y and x minus 2y, if you will be foiling them, and then and so on and so forth, you will be getting this three terms inside the parentheses. So therefore, what about the denominator? So we are done factoring the terms inside the parentheses. So what shall we do now? We are going to rewrite the denominator. Now question, is there any use in factoring the numerator and the denominator? Is there any greatest common factor? Let us try make some transformation. We will be transforming. Okay, let us try. I am rewriting 3 times x minus 3y in the numerator. We have this one. I am just rewriting whatever found here. And then in the denominator, we're able to uh, we're able to adjust. We're able to adjust this one. Uh, the 3y minus x, as you have seen, is there any relationship with this x minus 3y and the 3y minus x? As you have seen, uh, the 3y here is negative and the 3y here is positive. The x here is positive, the x here is negative. Thus, if they have exactly opposite or they are additive inverses to each other, then we can make it into this way. So remember, originally the x there is negative. So that's it. A negative times a positive x, it's still negative x. Remember, our 3y here is positive. Thus, we have to factor it out that negative times negative, we still have a positive 3y. So we are retaining the same value. So therefore, in this manner, we can now apply cancellation because there is that common factor. There is that greatest common factor. So far, the x minus 3y and the x minus 3y can be now cancelled. So if they are now can be cancelled, so what are the remaining terms? So the remaining terms in the numerator, we have 3 times x minus 2y, and then remember, we only cancel this one, so the remaining there is the negative. Okay, and for that, what is its final simplification? Okay, so how do we find the final form? We will be remembering that if we divide a positive and a negative, we will surely get the final answer to be negative. So positive divided by negative, so our final answer will be that negative could be written in the middle. So therefore, this is already our final simplified form in number 9. Okay, guys, I hope this is quite tedious. This is quite something that you have undergone processes, you have undergone some concepts, but I'm sure if you just only apply all these basic concepts in factoring, you will surely simplify a rational expression. Guys, I hope you continue watching my coming videos and I hope you learned something from this video today. This has been Teacher Justina and saying goodbye, and please do subscribe if you are not yet done subscribing. Goodbye everyone, that in all things God may be glorified.